Good morning, all of you. So in today's class, we'll continue with the applications of accelerated pure rolling. So what all we just yesterday I introduced, V coat R omega, then AC coat R alpha, forward slipping, backward slipping. The same ideas now will go for application. Different shaped like a spear, disc, everything, different rigid bodies. When you apply a force, then how particular things will come. All block upon a block. If I place some rigid body on a plank, if I pull the plank, or if I push a rigid body, what conditions will come here? So I think this will be a very generalized topic, this one. So almost you get a plenty of different cases. So here what actually happens is student must analyze here. You can't remember anything here. You must develop a methodology here so that you can tackle any of the problem. So from yesterday's discussion, what we had, like a rigid body kept on a rough horizontal surface, then it is pulled by a force acting at the center of mass. This one. Then what we have seen is, what we know is the friction that is acting, is a rolling friction. The friction acting is a rolling friction. Now, let me just put all the things in order. Yeah, I think we stopped yesterday till here, no? Okay, the friction that was acting, it was a rolling friction, that one. And this rolling friction depends on what? Depends on applied force and also the distribution of mass. I agree this. Then one more thing. What about the other forces? The other forces which are acting are the weight and the normal contact. What is the work done by the weight? Because what action the displacement is? The displacement is towards right. The displacement of that rigid body is in fact towards right. So where is the rigid body now? The rigid body is initially, it is here, no? So after some time it has come, it will undergo displacement. What is XC? Displacement of center of mass. How the rolling friction? The rolling friction will act here. Acceleration of center of mass. It should be like this. Huh? Acceleration of center of mass. Then alpha C will come. It will set up a torque. After some time, it will be there. That is what the displacement of center. It will not be there only. It will rotate and also move. I think all of you might have done yesterday. I told you, just take any cylinder, container, push it, or when it starts rolling, no? Or you take any spear, start pushing it, it starts rolling here. Now, what is the friction? It's a rolling friction. What is the work done by it? What are the forces acting? Normal contact and weight mg. So what is work done by normal contact? Work done by normal contact is in fact zero, because how it will act? It will act perpendicular to displacement. Then what is work done by the weight? It is also zero. It is also acting perpendicular to displacement. Then what about work done by friction? As friction does both translational work as well as rotational work. Shall I put like this? X and theta, translational and rotational, or T and R, I'll write it. Translational work done. It does negative work. Then what about rotational work? It is setting up a torque, no? F into R into theta. And for accelerated pure rolling, what do you mean by that? AC is equal to R alpha C. VC equal to R omega C. At this particular point, what is the state of the rigid body? It will have acceleration of center of mass, it will have angular acceleration, it will have angular velocity, and the center of mass will also acquire velocity. Then for accelerated pure rolling, what we write? AC cot R alpha C, VC cot R omega C, then also X is equal to R theta. Theta is what? Not angle, it is a angular displacement. I'll put it again. What is omega c in fact? In fact, d phi by dt. Angular displacement of what? Of the radius vector. The radius vector, this will be rotating, no? This body will be rotating, will be rolling. The radius vector will be rotating. This what this one. Fine. So we'll get this much here. So now x equal to r alpha, alpha you substitute. Then how much this equation will come? Minus xc plus fxc. Net work done by rolling friction is 0. So who does work? Only the applied force. But so like who will make it to rotate? The friction only. But net work done by rolling friction will be 0. Now there's a very fundamental thing which you have to remember here. Very, very, very important. When it will be 0? When pure rolling, for no slipping. Net work done by rolling friction is 0 in pure rolling. So we'll put that statement. In pure rolling. Agree with this? What do you mean by, sir, pure rolling? AC is equal to R alpha, acceleration of point P along x-axis must be 0. Means here also forward, backward slipping will be the S. Here also what happened? We are going to get forward slipping, backward slipping ideas. Here only let me introduce. What do you mean by forward slipping, pure rolling? Once again, pure rolling, AC acceleration of point P will be 0. AC is equal to R alpha C. Acceleration of point P along x-axis will be 0, and because of that AC equal to R alpha. In forward slipping, acceleration of point Px will be greater than 0. Where AC will be greater than R alpha C. What about in backward slipping? APX will be less than 0, where APX equal to AC minus R alpha C. So definitely what it shows, AC less than R alpha C. Like similarly how we had in velocity pure rolling, here also accelerated pure rolling will come into the picture. Okay, there's a one thing. Next again, let me come back to again. I'll keep on increase the applied force. Rolling friction will also increase. Sir, is there any upper limit for rolling friction? Is there any upper limit for rolling friction? What is the maximum permitted value of any friction? Should be limiting friction. So therefore, for any value of applied force, will the rigid body will roll? The answer is no. The answer is no. So what is the maximum permitted value of applied force for which the body will have pure rolling? So what we say is like the friction is sufficient for pure rolling. What does it mean? The force applied on the rigid body is such that that force is less than the force is acting and the friction acting is less than rolling friction. So what is the maximum permitted value? So when F becomes FL. So this is something very important. Then F will become, go back to the slipping. I'll keep on increase the applied force. The friction will also increase. The friction will also increase. So what is the maximum permitted value of friction? Equal to limiting. So therefore then applied force will be maximum. So any force applied less than F max, there will be no slipping, pure rolling. If applied force is greater than F max, there will be a slipping. So how to calculate that F max? So I'll substitute here. FL equal to F into 1 plus mr square by IC. So this should be equal to 1 plus mr square by IC into mu s mg. So if F greater than F max, no slipping. F less than or equal to F max, no slipping. F greater than F max, slipping will occur. This is something very important in numericals. This is a hidden condition. In books, I think they didn't stress it much. For any value of applied force, well, the rigid body will have pure rolling. The answer is no. Any reason for that? The background is this one. Huh? So now what shall I put? So I think I'll push it down. All these are a very good theoretical ideas. One must know, even teachers, student, anybody must know before entering into the rolling motion, accelerated rolling motion. So what is the conclusion I'm making? F less than or equal to F max, pure rolling. F greater, applied force is greater than F max, then it will be slipping will occur.
Sir,
Ah.
is mu s a static coefficient, sir?
Yeah, mu s will be coefficient of static friction. Not mu r. It should be mu s only, strictly. So what is the rolling friction? Rolling friction, what happened? Don't call it say static, don't call kinetic. It will come into existence when the body is having a rolling. The friction that will act on a body when it's having a rolling, when you apply external force. Again, if you just give velocity and release on a surface, then kinetic friction will come as usual. I think this is a for all the values of applied force, the rigid body will have pure rolling. Wrong statement. I think this condition is being put. So instead of this in the books, how they say the friction is sufficient for pure rolling. What does it mean? What does it mean? The applied force which is acting on a rigid body is less than F max. There's a meaning of that one. Huh? Please do understand here. This is very important. The applied force, the friction is sufficient for pure rolling. What do you mean by that? What is the meaning of that? The applied force acting on rigid body is less than F max. That's the conclusion. Finish over. We should have that background clarity like this. Okay, let me go for the next part. Just I think